In this lecture, I'm going to talk about our first approach to modeling people, and this is known as the rational actor model. Now, the rational actor model assumes that people are, well, rational. We make optimal choices. And it comes under a lot of criticism, increasingly so, as people are dissatisfied with some of the results it produces. Nevertheless, I'm going to argue this is a really useful way to think about people, especially when we're constructing models. So what I'm going to do in this lecture is the following. I'm going to describe how it works. I'm going to describe the rational actor model first in the context of decisions, and then I'll do it in the context of games, which are strategic interactions, where my choice depends on your choice. After I do that, I'll talk about, give an example where it sort of breaks down, but I'll talk about sort of why I think the rational actor model is really a useful thing to have in your pocket. Well, it's a useful way to analyze situations. Okay, so let's get started. So how does the rational actor model work? Well, what you do is you assume that people have some sort of objective. That objective could be, any one of a variety of things, but there's some goal or purpose that somebody has, or a group has, or a firm has. Given that objective, we assume that you make optimal choices, that you optimize. Again, strong assumption, but that's what the approach assumes. There's an objective and that people optimize. So how does that work? Well, let's suppose it's a firm. If you're a firm, what you might want to do is you might want to maximize profits. Or you might want to maximize market share, right? Or you might want to maximize total revenue. Those are all things that a firm might want to do. If that's your objective, what we assume in the rational actor model is that you do that. You make the choice that maximizes that goal. Now, if you're a person, you might care about maximizing your own utility, making yourself as happy as possible. Or if you're altruistic, you might care about not only yourself but other people. Again, the presumption, though, is that whatever your objective is, that you make optimal choices to satisfy that objective, to do as well as you can possibly do. If you're a political candidate, right, what you might do is you might care about getting as many votes as possible. So that's your goal, that's your objective function, get votes. And the rational actor model assumes that you take the action, make the choice that gets you as many votes as possible. Okay? So where can you apply this? Where can you apply the rational actor model? Well, let's take this simple case of a firm. And what they want to do is they want to maximize, let's say, revenue instead of profits. And suppose that the revenue, we can write it as this way, right? It's just price times the quantity. That's how much revenue we're going to get. And let's suppose if we let the quantity be Q, that the price will be 50 minus Q. Now, why would this make sense? Well, if the Q is 10, if I only produce 10 of these things, then there's not money to go around, and maybe I can charge $40 a piece for them, right? So the price would equal 40. But if I produce more of these, if I produce 20, then there's more to go around, and that's going to cause the price to fall, and the price to fall to 30. So in this first case, I'd get a revenue of 400. In the second case, I'd get a revenue of 600. So the question is, what Q do I choose to maximize my total revenue? And if you think of this, my total revenue is just Q times 50 minus Q. So the optimal thing to do is going to be to have those two numbers be equal. So to choose Q equals 25, so I'll get 25 times 25, which is 625. So my optimal choice is Q equals 25. So what a rational actor model would assume is the firm wants to maximize revenue. That's the objective function. And then given that, it wants to choose a quantity that will do so, so it chooses Q equals 25. So where can you apply this? You can apply this just about anywhere. So you can think about if I'm making investment decisions, I've got some objective, and that may be to maximize the value of my portfolio or to give me some sort of nest egg to retire on. And so I'm going to make choices that maximize that. Or think of my purchases, right, or your purchases. Like when you go to the grocery store, or if you think about buying furniture for your house, you could assume you've got some objective function, and what you do is you make choices, right, that are optimal given that objective. Even things like education level, you just said, how many years of school should I take, right? Should I just get a bachelor's degree? Should I get a master's? Should I get a PhD? Well, you could assume that, like, you've got some objective function, which could be you maybe care about income, you may care about what sort of life you lead, is it a life of the mind, is it physical labor, and you choose how much education to get given your objective. Now, you can even apply these things like, how do I vote, right? Because my objective could be for some policies to be implemented. So therefore, I look at the candidates and figure out which candidate is likely to vote, implement policies that I want. Now, you also probably want to figure out, is that candidate likely to win, right? I don't want to vote for someone who espouses my preferences but has no chance of winning. So what I do is I sort of choose the candidate who's likely to win, or most likely to win, who also takes positions like the positions that I prefer. Here's an issue, though, that I want to bring up. When we assume rationality, people often think that that means selfish. That's not true. So let me give an example. Suppose I'm walking down the street and I find $100. Well, and I'm walking with a friend. So there's me and there's my friend. So one possibility is I could just say, you know what? This is so cool. I just found $100. I could put it in my pocket and give my friend nothing. That would be rational if my objective function was just me, if all I cared about was myself. But it could be this is a really good friend and I care a lot about my friend. And so when I found the $100, I say, hey, wait, whoa, this is great. I just found $100. So I walk into the nearest store and say, can you give me 2 50s? And I give one of the 50s to my friend because I care a lot about my friend. So there's nothing intrinsic about the rationality assumption that assumes selfishness. So again, selfishness would just say that my objective function is me. This is how we put it in the framework. All I care about is me, my happiness, my income, my wealth, right? Altruistic preferences would be that my objective is that I care about other people as well. So I care about not only about the happiness of myself, but I care about the happiness of others. And I can do all the same mathematics, right? So here's an example, just like the price quantity example, involving an altruistic person. So suppose I've got someone who's got an income of $40,000, and they've got to decide how much do they consume and how much do they donate. And their objective function is just the square root of their consumption times the square root of their donations. And they want to think about how much do I donate and how much do I consume if this is my goal. Well, this is just a mathematical problem, right? So my donations are just 40,000 minus whatever I consume. So this is just the square root of C times the square root of 40 minus C. I can bring everything under the square root sign and get the square root of C times 40 minus C. Well, now looking at it this way, you realize I want to make C times 40 minus C as big as possible. And the way to do that is going to choose C equals 20 so that D equals 20. So the optimal thing to do here is to consume 20 and donate 20, to split my income halfway between consumption and donation. That's rational. It's also incredibly altruistic. I could be irrational and altruistic and possibly consume less or more than this, right? And I could also be irrational and selfish. But the point is that rationality, right, does in no way assumes selfishness. You could be rational and altruistic. You could be irrational and altruistic. Now I want to move on to something that's sort of complicated. That is, I want to make a distinction between this decision and a game. So in the previous example, that was a decision. I had to decide how much to consume, how much to donate. In a decision, my payoff, what I get, only depends on what I do. In a game, my payoff depends on what other people do. This is where it gets tricky. Because for me to decide what I'm going to do in a game depends on what I think the other person's going to do. So therefore, I need a model of what I think the other person's going to do. And oftentimes, a really good model to have is to assume that the other person is rational. And that's a lot of how game theory works. A lot of game theory assumes the other person is rational, and that allows you to figure out what you're going to do. So here's an example. Let's suppose there's 2 people. Let's call these people person 1 and person 2. And this is what's called a normal form game. And this is a game payoff. I'll explain this in a second. So person 1 can decide whether to stay home or go into the city on a Saturday, as can person 2. If person 1 stays home and person 2 stays home, person 1 gets a payoff of 1. If person 1 stays home and person 2 goes to the city, person 1 still gets a payoff of 1. So person 1, if they stay home, their payoff is just 1. It's also true if they go to the city, person 1's payoff is just 2. So 1 if they stay home, 2 if they go to the city. Person 2 is a more complicated person. Person 2, if they stay home, their payoff is also 1. But if they go to the city, their payoff depends on what person 1 does. So if person 2 goes to the city and person 1 stays home, person 2 gets a payoff of 0 because person 2 is lonely. It's no fun to go to the city alone, at least for person 2. But if person 2 goes to the city and person 1 goes to the city, person 2 gets a payoff of 4. Well, look at person 2's choice here. This is hard. Person 2 is trying to decide, do I go home? Do I stay home or go to the city? Well, if person 1 is going to stay home, then I should stay home because 1 is bigger than 0. But if person 1 goes to the city, then I should go to the city because 4 is bigger than 1. Because it'd be really fun to go to the city. Person 2 is like, but it'd be great to go to the city with my friend. So for person 2 to figure out what to do, person 2 has to know what person 1's going to do. Here's where an assumption of rationality is really useful. Because if person 1 says, I have no idea what person 2 says, I have no idea what person 1's going to do. I'm clueless. Then person 2 can't figure out what to do. But if person 2 says, I think person 1's rational, then person 2 would say, well, look, if person 1's rational, if they go to the city, they get a payoff of 2. If they stay home, they get a payoff of 1. So I bet they're going to go to the city. So therefore, if person 2 thinks person 1's rational, person 2 thinks person 1's going to go to the city. So therefore, person 2 goes to the city, and they get this great payoff. Okay, so That's where, when you think about decisions you have to make in the real world, you often have to have some model of what other people do, and oftentimes a decent model is to assume the other person is rational, right? That they're going to do the rational thing. Let's do another example. That was an example of what we call a normal form game. This is an extensive form game. Now, an extensive form game, these are sometimes called game trees, and we sort of draw the actions sequentially. So here there's a green person, right, and a blue person. So the green person's going to go first, and they've got to decide, do I go this way? And if I do, we both get payoffs of 0, or do I move down here? And if I move down here, the blue person gets to move. So the green person's got to decide, what do I think the blue person's going to do? Well, if the green person passes it down to the blue person, he looks and says, well, the blue person can move over here, and the blue person will get 2, and I'll get 2. Or the blue person could go straight down, and the blue person will get 3, and I'll get -3. So if the green person assumes the blue person is rational, the green person is going to say, well, look, 3 is bigger than 2, right? And so the blue person is going to move down here. Well, then the green person is going to say, boy, even though I could get 2, 2, I'm not going to get it. I'm going to get -3, so I'm going to move over here. So again, here, by the green person making a rationality assumption on the part of the blue person, the green person can figure out what to do. Okay. So when would we see rationality? Rationality seems like a strong assumption. First case is when the stakes are really large. So if you think about it, like if you're just in, buying lunch somewhere, maybe you just follow some rule of thumb, right? Or if you're trying to decide, exactly how many bagels to buy at the bagel store, maybe you just sort of pick a dozen or something. But if you think about buying a house or buying a car, or deciding where to go to college, or deciding whether to go to college, those are large stake decisions. And in those situations, it's probably the case that you come fairly close to being rational. Okay? When else? When it's repeated. So there's been a lot of experiments on whether or not people are rational. What we often find is the first time somebody does something, especially like, remember that Monty Hall problem with the 3 doors we did? First time people do stuff, they often don't get it right, right? But the more and more you do it, people tend to learn, and we get closer and closer, right, to being optimal. Third case, when you have groups of people making decisions. Now, groups can get led astray, and you can get groupthink and terrible choices and escalation of biases and that sort of thing. But typically, if you bring in more people, you're less likely to make an irrational decision. That's why when we're making large stake choices, right, we often go and ask friends and family and other people who respect so that we're not making these decisions alone, so that there's some sort of group of us making the decisions. And then last case is, one reason we make optimal choices is often optimal choices are easy to make. And somebody says, would you rather have $20 or $10? We choose 20. If someone says, would you rather do less work or more work? We typically say, I'd prefer to do less work. So why then, if rationality is often too complicated, and why, if we just think about it, people don't act rationally, why make the assumption? So one of my advisors was a guy named Roger Myerson, who won a Nobel Prize in this area called mechanism design, which is sort of a branch of game theory in a way. And Roger makes this following compelling argument, that rational behavior is an incredibly important benchmark. It's probably the most important benchmark if you think about modeling people. Why? Well, first off, it's unique. Most of the time, not always, but most of the time it's going to be unique. So think about the case of the firm deciding how much quantity to produce to maximize revenue. Or think of the person trying to decide how much to donate to charity. There's a unique answer. So it gives you this definitely testable amount, right? You can say, this is what rational behavior is. Okay? Second thing, it's often really easy to solve for. So even though we think rationality is hard in practice, we're writing down these mathematical equations, right? So I've got some function that looks like this. It's often very easy to use mathematics to find the optimal point, to find, within the context of our model, what someone should do. So let's contrast this with irrational behavior. Suppose I write down some model and say, people are irrational. Well, I've got 2 problems. One is, it's not unique, right? There could be 1,000 ways to be irrational, so I have no real prediction coming from the model. The second thing is, it may be really hard to figure out what exactly is it that this person is going to do in this context if I start taking in all these sort of psychological influences and contextual influences and that sort of stuff. It's often just easier to say, here's their objective function, let's just assume they optimize. Another reason it's an incredibly important benchmark. People learn. Remember we talked about these experiments that over time people get things right. Well, if over time you're moving towards the rationality assumption, then maybe the rationality assumption is sort of not a bad place to sort of start, and then you can sort of say, this is where we expect the system to go over time, right? And then last, it can be the case that even if people make mistakes, if there's no bias one way or the other in terms of the mistakes, those mistakes may darn well cancel out, and what you're left with then is something that looks pretty close to rational behavior. So some people could spend too much, some people would spend too little, and therefore on average you get something that looks close to rational. Okay, so what have we seen? What we've seen is this, is that rational behavior works from the following set of assumptions. You assume there's some sort of objective function, and then you assume people optimize, given that objective. And this could be firms, this could be people, whatever you want it to be. Now, strong assumption, yes, but a really powerful benchmark. Now, one of the things we found from doing a lot of experiments, when I say we, I mean psychologists, economists, all sorts of people, scientists, what we found is there are places where people sort of systematically deviate from rationality. That's what we're going to look at next. We're going to look at some specific biases where the rationality assumption sort of seems consistently not to hold. Now, there's going to be cases where it does hold. There's going to be cases where it consistently doesn't hold. Nevertheless, it still can be useful, even if you think it's not consistently going to hold, to think through your model, assuming rational behavior, to get that sort of benchmark, to see what would rational people do. That way, when you actually look at the evidence, you can see exactly how far from rational people really are behaving. Okay. Thank you.